Welcome everyone. This course is just about DevSecOps. Let's understand and learn about it from basic to advanced. In this DevSecOps full course learning series, I will tell you all that you need to know to become a DevSecOps engineer, DevSecOps consultant, or a DevSecOps architect, and much more. So let's Cybit. You are listening to Vinay, and I have more than a decade of proven experience in cybersecurity that includes DevSecOps program implementations as well. I'm delighted to be here again today to walk you through DevSecOps from scratch to advanced. This is our third full course learning series focusing security, or we can say computer security domain. Before this, we have already published first learning series, cybersecurity full course for beginners, and the second learning series for cloud computing and security. Please click on the I button and watch these two learning series as well from Cybit Cybersecurity collections that meets your learning requirement. So data security is one of the most important considerations within any organization. On a nearly continuous basis, we hear of a major data breach that has lost privileged customers as well as countless dollars. So how do you help safeguard your company's applications to protect against these losses? Well, this is where DevSecOps comes in. I designed this course focusing only DevSecOps in mind and divided it into 5 parts that will be published one by one. First part is about understanding and clearing our DevOps and DevSecOps concepts. Second part is going to be about automation in security testing with DevSecOps. By reaching to third part, you will be clear with DevSecOps concepts in detail, and then you are ready to learn about best practices and tools. In fourth video of this course, we will understand about consistency in application security with DevSecOps. Part 5 of this learning series will solely depend on the responses that I will receive in comment boxes that will address all the questions asked by you in each video's comment boxes for DevSecOps Learning Series. In today's video, I'm going to talk about 3 topics. DevOps Fundamental. I will show you how to drive security into a DevOps process. We will discuss DevOps and why traditional security testing doesn't work well within it. Then DevSecOps Fundamental, where we will examine strategies to speed up the security testing process and develop a DevSecOps approach. And post understanding and have a clear understanding with these 2 concepts, we will start our DevSecOps journey. Here we will talk about tools and methods to implement security testing automation. If you want to move your security testing to next level, this course is for you. So let's get started. So why you should learn cybersecurity or cloud computing or any other security domain concepts from me? I have an MBA in information technology following my bachelor's degree in computer science and engineering from A-grade universities in India. I have many internationally recognized technical certifications from renowned organizations like Microsoft, NetApp, Exin, ISC Square, and many more. But more importantly, I have work experience in real world from banking to telecom industry to product manufacturing and IT consulting firms. As an innovative expert in cybersecurity strategy, transformation, and consulting with total 12 plus years of experience, I have saved companies millions of dollars by pioneering first of their kind initiatives, combining business systems savvy with the latest technology and trends focusing compliance, ISO 27001, NIST cybersecurity framework, PCI DSS, GDPR, etc. I am skilled at devising and seamlessly directing the development of revolutionary solutions with maximized speed, efficiency, and cost effectiveness, spearheading the coordination of people from all backgrounds and levels, on and offshore bases alike. I have an outstanding track record of transforming concepts into state-of-the-art realities, which produce quantifiable improvements in profitability, performance, and business potential. Striking the optimal balance between technical sophistication and user-friendliness, I continually meet and surpass customer expectations. Experienced in areas spanning from R&D to sales, marketing, and business development, I have a unique ability to define 360-degree roadmaps to success, inspiring people to continually push the boundaries of possibilities. Because of my ability to manage all aspects of projects spanning from needs analysis to the deployment of best-in-class solution. Now I'm passionate about sharing my knowledge and experience. Instead of teaching boring cyber theories and security concepts, I teach based on my own real-life practical experience, and it has led me right here to you. So let's Cybit. Before starting a discussion on DevSecOps, we should start by making sure we have a good understanding of what is DevOps. Why does DevOps exist, and why does it seems like everyone is moving in the direction of implementing DevOps? Waterfall is gone. No one wants to use it anymore. It used to work in environments where quarterly or monthly releases were the norm. Weeks-long development followed by weeks-long testing followed by weeks-long user testing doesn't work. Client expect quick turnaround. They want to wait weeks, not months, to see their needs meet. They want defects fixed in days. Long development times will hurt reputation and could lose business. Technologies like cloud have raised expectations for development teams. When service can be started in seconds via code and becomes a hard sell that it should take months to release upgrades. With waterfall gone, Agile comes in and fills some of the gaps. Agile works to speed up the delivery of applications. It solves the problem of lengthy releases. Typically, Agile projects are organized by 2 to 3 week sprints. Multiple sprints will be organized into a product release. Having these small sprint cycles allow for quicker implementations of client feedback. Agile allows product owners to define sprint backlogs and development teams to prioritize work. Agile gives the business or clients the agility to say what works and what doesn't, and see that feedback loop work quickly. Development teams can rearrange tasks based on the bottlenecks or business priority. This gives everyone more flexibility. Agile solves a lot of the problem of waterfall, but it is still has some issues. We can't forget about areas that don't deal with the application, like building servers, patching, or networking. Consider the three major parts of an application lifecycle: development, testing, and operations. Agile solved the development and testing issues, but really didn't touch operations. Typically in the waterfall world, the three areas are kept separate and run by different groups. DevOps bring the three groups together. No more development team, testing team, operations team. They are the same group. One team performs all the actions or functions. One team has a responsibility for developing the application, testing the application, releasing the application, and keeping it running. No more segregation of duty or function. The DevOps team does it all. Agile and DevOps are not the same, but they typically go hand in hand. Agile is development technology. DevOps is a culture shift. It's a way of thinking about an overall application lifecycle. Now, not only can development move quickly, but the entire release can. Deployments, patching, testing, the whole process moves exponentially faster. The DevOps methodology empowers teams to closely define, develop, and release applications. They can all have input, and that input can be heard and acted on quickly. DevOps isn't easy. If someone says it is, they aren't doing it right. It's a huge culture change, not only for developers but for an organization. The business has to be more involved in the form of product managers. The technology teams have to form their teams that support a DevOps culture. DevOps requires skilled teams. You can't always take a tester and force them to be a developer. You can't always take a developer and make them be a Linux expert. You have to invest in finding the right people and making sure they have the right training. Everything needs to happen quickly and can't wait. Any process that is cumbersome or lengthy won't work. Whether it's performance testing or manual server deployment, long processes will drag down the project and won't be effective. The largest problem with most areas is the lack of automation. Without a mature automation system in place, true DevOps will struggle. It will be hard to achieve the velocity needed. Security is not immune to the effects of DevOps. That's why DevSecOps has to be achieved to make sure that security can keep up with the pace of the project. The quickest way for security to become irrelevant is to get left behind. So security is definitely different in a DevOps world. Let's take a look at how security has changed as our methodologies have changed over time. This is a graph based on a Sonatype survey showing where in the life cycle application security testing was completed. It has responses from 2014 and 2017 and also includes responses from people who are mature in their DevOps practices. There are three interesting things that I picked from this graph. One is that in 2014, which is the responses that are in blue, the largest percentage of people did the application security testing in production. The second thing to note is that in the mature DevOps practice, testing is scattered throughout the lifecycle in large percentages. And third, 60% of the mature DevOps practices, organizations did testing during QA and test, which is a lot earlier than they did in the previous lifecycle in 2014. This is what a normal security scan looks like. Code is developed, the code is sent to the security team. The security team reviews it, creates a PDF, looks for false positives, and then finally the security defects are fixed. This typically takes 1 to 2 weeks and is a very manual process. Usually source code has to be gotten, dependencies have to be resolved, false positives have to be weeded out. In the and it's very cumbersome to do, and it just won't work in a DevOps model. It's too slow. In 1 to 2 weeks time frame that it would take to do a typical static test, you are already on to the next sprint. Too many people are involved. The security team has to run the scans. The development team has to be involved to give you the source code and work with you to resolve any problems during the build. And there's no empowerment of the dev teams. In a DevOps world, the development teams need to have the power to be able to run the scan themselves. In the old model, the scans were run by the security team and the results were simply handed over to the development team to review. When you are doing security in DevOps, there are two things that we should think about. The first one is how can we be quick? Instead of 1 to 2 weeks to turn around the test, how can we turn around a test in a matter of hours or a matter of minutes? And what's going to be the one that responsible for running the test? Is it the security team? Is it the development team? Who should be the one that's actually responsible for it? Time matters in an agile or a DevOps world. Anything that we can do to make it quicker will really help to process succeed. So three areas that we are going to focus in on in the upcoming video are automation, education, empowerment of dev teams. We will dig a little bit deeper into each of these three and show how these can help speed up and educate the development team to be able to perform their own security and empower them to be able to responsible for their security of their platform. Before we move on to the next video, Jenny Kim, who's one of the biggest founders of the DevOps movement, has a great quote that I think is very appropriate to what we are talking about, which is the only thing more dangerous than a developer is a developer conspiring with security. In the next video, we will take a little bit more about DevOps, DevSecOps, and how we can create that separation, but still create the accountability within the security team. Now let's talk a little bit about DevSecOps and how to integrate security into the DevOps world. The definition of DevSecOps really is how to take security and put it into the DevOps process. How do you merge the two together and still make sure that for a security perspective, you have all the checkpoints that you need to implement. When you are developing a plan of how to do this, the goal really should be to how can we make the dev team have more ownership of the process. It's not all about automation, but it's about ownership and accountability, and how can we get the dev teams to take more of it. Integrating automation into every step of the process is going to be the key. One point I would like to bring up is the distinction between the terms DevSecOps and rigid DevOps. Many times they are used interchangeably, but there is a distinction. DevSecOps focuses on the whole development lifecycle and the security automation that supports it. Rigid DevOps is more specific to developers and supports developers during extreme testing on their code to ensure it's protected once it's released to production. For the purpose of this course, we will focus more on DevSecOps. As with all DevOps, automation is the key to DevSecOps. It's how you are going to be quick and agile and get away from all the manual processes that you had. There's a good chance that when you move over to DevSecOps, some of the tools that you have used for years with your existing process won't work. Even if you can automate the tools, the amount of false positive that come with them won't make them worthwhile in a DevOps pipeline. Everything has to happen quickly. So with static scans, it used to take hours. These won't work anymore, and we really have to rethink how do we do it, how do we automate it, and what tools can we use. The automation of security tools doesn't mean automating pushing a button. It doesn't mean taking your dynamic scanner and automating clicking of run scan. What automation means in security tool world is that you can put something in a script and have it run in the background and push meaningful results to your developers. Not a PDF, not a document, but actual results in the developers. And the results should be pushed into a tool that they use, not a security tool that the security team uses, but something that is meaningful to them, like a Jira or a quality center that they are in and out of all day long. That's meaningful to them. And that is real time so that they can act on it. And even taking that one step further, one of the best ways that you can enable the development team to have the results in real time is through chat ops. So instead of sending them PDFs, send them notifications via Slack or HipChat or some other immediate notification mechanism that they have to be able to act on the result quicker. And one of the more popular quotes that I have seen and that I really like is by Rod Michael, and he says, if you automate a mess, you get an automated mess. So make sure that when you do your security automation, that you do it in a way that helps the developers, not hinder them, and provides them good result that they can act on. The second part of DevOps I want to talk about is education. The developers need to be educated on security basics. In the 12 plus years that I have been doing application security, I have seen the same security defects over and over again. SQL injection was a problem 12 years ago. SQL injection is a problem today. So helping the teams understand the security basics will really help to speed up the development process and the DevOps process by having them know upfront what they need to be coding for. Ensure that they have the resources to be able to fix any defects that they may find. The idea here isn't that security is not going to play a part, but the idea is that we will give them the information that they need through training, through help, through conversations, so that they can fix any of the defects that come to them. And just like with all DevOps, the key to DevSecOps is really let developers own their own security and be responsible for their security. The last point to be made for DevSecOps is that we need to empower the dev team. Give them the tools, let them hold the tools, let them put them in their pipeline the way that they can use them. Put them in their Jenkins build or put them in their ID so that when they are building an application, they can see the results in real time. Ultimately, they should be responsible for the security of the app, not the security team. The goal here is to flip the security team to being an auditor and not a tester, so that we can make sure as a security team that the testing is done. But we are not the ones actually doing the testing. That is the dev team. Let's talk about shifting security to the left. We hear a lot about that in the IT industry today. But what does that actually mean when we shift things to the left? In security, that means taking a lot of the things that we used to do in the QA or in production or later in the life cycle and moving it closer to the development phase. This goes along with a lot of what we talked about in the first chapter. Most of the people tend to perform testing at the end or at scattered times. When we move security to the left, we take things that we used to do in production like vulnerability scanning, or in QA like static and dynamic scanning or interactive scanning, and we move those to the development phase. Just like everything else in DevOps, security has to be moved to the left. It has to be done more quickly. It has to be done by the dev team, and they have to own it. The challenge is they have to be the jack of all trades. Not only do they have to be developers and server administrator, but they have to have a fundamental understanding of security as well. A prime goal of DevSecOps is to enable development. We have talked about that as a whole in DevOps, that we want to enable development in DevSecOps that follows that same trend. We want to enable them to be able to do their own security testing and own their security. How do we do that? A security team has to provide a few things to the developers. Like we talked about before, we don't want to just hand security over to the developers and say do it. We need to provide them some guidance on how to do that. Security team needs to provide a framework. What type of tests do they need to run? Do they need to run static or dynamic or interactive? What things should be fixed? What are considered critical? What are considered high? We need to be able to provide them a framework that they can work within. To go along with the that we need to tell them what tools that they should be using. Some tools work better than others. Some work better on Java apps, some work better with different type of authentication. We should provide them the tools that they need to be able to be successful. Finally, the security team should provide the expertise. We are still the experts, and we should help them understand how to fix issues. How should they prioritize them in a sprint plan, and how could they be exploited? The security team and DevOps team really should be considered as partners. It's their job together to jointly ensure that application is secure. The DevOps team is responsible for the application security testing and ensuring that the application is secure, but the security team ultimately is accountable for it. If you remember, the security team turned themselves into auditors, so it really is a joint partnership to ensure that the application is released securely. Really, in DevSecOps, we should think bigger. Shifting left is great, and that's what everybody in the industry kind of says. But we should really be thinking bigger when it comes to DevSecOps. We should shift everywhere, not just early or not just left. Defects can be found at any part of the application lifecycle. It could be found in the development. It could be found in the testing. It could be found in the production. Production code does have vulnerability. When we are rolling out our DevSecOps process, it's important to think shift everywhere, not just to the left. Previously, we have talked about cloud. So the question becomes, how does cloud and DevSecOps relate? First, let's talk about some of the goals of going to the cloud. I think that the goals that many businesses have when they go to the cloud are the same. The first would be speed. You can launch machines faster, you can deploy faster, you can patch faster. Everything in the cloud has the ability to go a lot faster. And kind of going hand in hand, that is, you can be more agile in the cloud. You can respond to business decisions quicker, or you can adapt. You can spin up more servers to handle processing that may happen sporadically. You can be a lot more agile in the cloud that you can with on-prem. And finally, cloud can be more secure. Inherently, there are some problems with going to the cloud, but cloud makes security a lot easier than being on-prem. Some of the problems that we faced when we dealt with servers on premises for years can be dealt with very easily in the cloud. A good example of this is network segmentation. Historically, a lot of our on-prem network have been flat, and to be able to segregate these requires a lot of manual work from the network teams or expensive software. In the cloud, they make this very easy, and you can set up different VPCs or different network access controls in order to segregate applications according to business need. And it can be done very quickly and easily with different APIs. So DevOps and cloud really are partners. You can do one without the other, but you really have a disadvantage. And to truly capture the value of either, you need both. When you step back and think about it, the advantages of DevOps and the cloud are the same, which is why they partner so well together. You go to DevOps to be faster and more agile and to be able to respond to your business needs quicker and adapt. You also have the ability to be more secure in DevOps model and to do so quicker. The only effective way of going DevOps truly is by going in the cloud. You could do DevOps without going to the cloud, but it would be very hard. You lose a lot of agility that's needed to do DevOps well when you deal with physical servers and on-prem hardware. The location of the cloud doesn't really matter. The cloud could be internal or external, public or private. As long as it's a cloud that can be easily managed and maintained via an API, you can still get the advantages of DevOps and DevSecOps. Let's talk a little about APIs and why they are so helpful to DevSecOps. Just like cloud is a good partner of DevOps, APIs are a great partner for DevSecOps. What is an API? An API stands for Application Program Interface. It really allows you to remotely connect to an application from the command line. It's an easy way for a developer or a tester to be able to get information and receive information from an application directly from a command line or a web interface call without actually having to bring up a user interface. A good example of this would be Web Inspect in the security world. So many people are used to starting a scan manually in Web Inspect, where you bring up the tool, you enter the address, you start the scan, you do the scan, get your results. All of that can be automated on the back end. Web Inspect has an API where you can launch a command line called Web Inspect Tell. It can what address you want to run a scan for, and get the results put into database, all without actually having to log into the application. So an API allows you to get data, send data, and even start a process remotely. And all of those things are really helpful when you get ready to start automating your application pipeline. The static scanners that we used to use for many years really don't work in a DevSecOps world. So we have to look for smaller tools and APIs. So as we roll out the tools to the developers. But looking at APIs, it allows us to do a few different things. It allows you first to use remote scanners. So instead of having to have a scanner installed on the developer machine or on the build machine, you can use the remotely. It could be your vulnerability scanner or your dynamic scanner, either of those. They have APIs built into them so that you can easily call them without having to launch the tool. APIs also enable you to be able to connect to defect tracking systems or testing systems so that you can update the status or send defects or add tasks remotely without having to log into GRR Quality Center or whatever the teams happen to be using. So APIs really take a lot of manual part out of the DevSecOps pipeline. It allows you to easily script and be real flexible and how to roll out your DevSecOps to your developers. The easier it is to roll security to developers and automate as much as possible, the more likely they are to adapt it and not have problems. In previous videos, we saw that DevOps and cloud were great partners. Well, automation is also a partner. It is really these three things that work together that will really help enable DevSecOps to function well in DevOps environment. As we roll out DevSecOps, one of the most important things that we can do is find the right tool set. It's also one of the hardest thing to do because sometimes we just don't know where to start. The best place to start is to look and see what you are currently doing. It's very possible that some of the tools you are currently using will work just fine in a DevSecOps pipeline. But at the same time, don't be afraid to throw out the old tool set and go with a new tool set if what you are doing doesn't work. And make sure that the tool selection is a team effort. Remember, developers and security are partners in DevOps team. We need to work together to make a tool selection, not make one in isolation. It's important to make a tool selection that will support developers and work with the tools that they use. So when making a tool selection, what should we ask? The first one is, what languages do we need to support? Some tools work better with Java or .NET. Some work better with some of the newer technologies like Node.js. It's important to understand all the different languages that your project will use, so that you can make sure that your tool supports that. What technologies do you use? Does your application use anything like Docker or a cloud? It's important to make sure that when you make your tool selection, you take these into account as well. What type of test do you need to cover? Some tools are better than others at different level of test. Some excel in looking for things like buffer overflows, and some do better with authentication. It's important to understand what types of testing you are looking to do, and make sure that your tools cover those. How lightweight is the tool? Is it something that's portable, that can move from environment to environment and team to team? Can you easily give it to the development team, or so that they can run the scan themselves? Can it be automated? Can the development team put it in their Jenkins pipeline, or run it manually on their machines as a part of their unit testing? And how long will it take? Will it take 30 minutes, an hour, or will it take 2 hours? We want to make sure these scans as easy as possible, as quick as possible, so that the developers can get the feedback they need. Open source is okay. In the past, we have been so concerned with commercial tools and ensuring that we have adequate coverage, and we convinced ourselves that you need to buy commercial in order to make sure that you had proper security testing. But what we are seeing in the open source community today is that there's a vast selection of good open source tools that do a great job of testing. So don't rule out commercial and don't rule out open source. Consider them both as you are looking for the right mix. Consider different tools for different applications. You don't have to have the same tool set for all your applications. In the places where I have worked, we have had hundreds of applications across our different areas. It would be impossible to have one tool set for all of them. So it's okay to have different tool sets, because you are going to have different technologies across your stack. And the key really is just try and make it as possible as easy. Don't have 50 tools. Don't have tools that take a long time to scan. Try and make it as easy as possible. Make it quick and have the fewest number of tools that you need to have appropriate coverage. Let's talk a little bit more about different type of tools that are on the market. Some of these have been around for a while, but some of them are a little bit newer. Static application security testing, otherwise known as SAST, really looks at the source code of the application and tries to look for security vulnerabilities before it's compiled. Most of the tools that are on the market today support multiple languages, especially the commercial ones. But the problem with these tools is that they tend to have a high false positive rate. The reason behind that is because it's not able to track the data very well as it moves through the application. Sometimes a tool is guessing as to what it thinks the application is going to do, or where the data is going to go, or where it receives the data. So when we look to integrate these into our CI/CD pipeline for DevSecOps, we really need to take into consideration and make sure that the tool that we choose has a lower false positive rate. Some of the more popular tools that are on the market commercial side would be Fortify, AppScan, and Checkmarks. Each of these work a little bit differently, and they have different advantages. On the open source side, Flying Secbugs, Brakeman, PMD, those are more some common ones that you see. And a lot of times the open source ones tend to be more language specific, so they may not have not have as broad of a coverage as the commercial ones. But There are a lot of different open source tools out there that cover all the different languages. Dynamic application security testing. These basically run automated hacks into the system. Once it understands a URL that it's targeting, it will spider the website trying to understand all the different pages, and then it will work for all the different inputs and try and hack into the application. These scans tend to take a long time to complete depending on the size of application. Some of the commercial ones are WebInspect, BERT, and AppSpider. Once again, they all have their ups and downs, but they are all really tried and trues on the market. Zap is a good open source alternative that many people use. It's lightweight and it's automable. Interactive application security testing, otherwise known as IAST, is one of the newer types of test tools on the market. The security tests are actually happening while the application is being used. So while the team is unit testing or QA testing or UAT testing, the ES tool is testing in the background as well. It works using something called instrumentation. It's very similar to perform monitoring tools like AppDynamics in the way that it works. It works at the Java runtime or .NET runtime level, and it looks at all the code as it's being executed, and it can see the code and the data that's going back and forth. And it can even see the SQL queries that are called. It really tends to have a low false positive rate and provides you immediate feedback because it can see the data as it flows back and forth. And it can see the code as it's being executed, and so it has the ability to do security testing on the fly. Since it's new, there are limited commercial tools on the market. There are no open source tools yet that are available, but on the commercial side there are two well-known ones. There's Contrast and Seeker. With AS, security testing is performed while all the time testing is happening. Because of that, it can provide immediate results to the dev team through chat ops or by pushing defects to their issue tracker, so they can run upon them quickly. This makes ES perfect for DevOps security testing. One of the most important thing to realize about finding the right tool is that change is okay. Don't be afraid to change it up or experiment to find out what works and what doesn't. That's the whole point of DevOps in general, is to adapt and continually get better and use feedback loops. So when you are doing your testing and you hear from dev team that you are getting a high rate of false positives, look for another tool set. Continually try to improve and provide the best results possible in the shortest amount of time. Another important concept in DevOps and DevSecOps is continuous integration and continuous delivery. Process looks basically something like this, where you have continuous integration and deployment that is going on either once a day or many times a day, and the cycle continues and continues. Continuous integration is the first step is the process. What this means is that when a developer is finished writing code or on a scheduled basis several times a day, the code is automatically checked in. When the code is checked in, it is integrated into a shared environment with the other developers, at which point integration test will occur to ensure that that the application is ready for deployment. The CD part of CI/CD usually stands for continuous deployment. It's the next step typically after the CI checks pass. It is an automated release to production that happens as soon as all the unit tests pass and the build is determined to be ready. Normally this goes together with continuous integration, but it doesn't have to. CD can also mean continuous delivery, which is similarly to continuous deployment. Expect the build may not be released every time to production. The advantages of CI/CD are similar to the advantages of DevOps. It's very fast and agile. When you do one build or multiple builds a day, that really enables you to be fast and agile with changes that you are making to your application. Along the same lines, CI/CD allows you to be lower cost and have shorter feedback time, because the sooner that you find problem either with the application itself or with the customer requirements, the lower cost it will be to fix. The sooner you fix something in the development life cycle, the lower the cost. One of the challenges of CI/CD was also one of the benefits. The fact that it's very fast is also a challenge. You have to be able to do your testing quicker, you have to be able to do your coding quicker and your deployment quicker, and that's really forces you into a different mindset of development and testing. That's why typically security processes here won't work. When you are doing one build or multiple builds a day, static scans that take a day or two or three to run just won't work. In the next couple of minutes, we will talk about how you can integrate your security into your CI/CD process. One of the new and popular ways to deploy applications today is with containers. Containers are another tool that can be used in the DevSecOps process. Let's take a look and see what containers are and how they can be used in security automations. A shipping container is a pretty accurate way to depict an application container. A container takes software and puts it into a single package for deployment. So picture taking your operating system, your application server, all of your application code, put it into one package and deploying that across the environments, as opposed to having all of your automation do a build and deploy, and having all of that, everything is packaged into one place and you deploy an entire container across environment. It tries to make configuration and deployment a lot easier, which really fits in well with DevOps process. And also from a testing point of view, it helps to ensure that environments are the same. When doing security testing one of the problems that's very common is that your environment are not the same. Your development environment is set up one way, your testing environment is set up another way, and your production environment is set up another way, which makes security testing cumbersome and difficult because you can't guarantee that results in one environment are true for another. Containers help solve this problem for us by making sure that all of your deployments are the same across environments by literally moving the entire application stack from environment to environment. An example of what a normal application structures look like this is pictured here. You can see that each application or each part of the application has their own separate server. A web server will have their own servers with the host OS, the libraries it needs, and then Apache or whatever happens to be running on top of that. And the same thing with the application server. In a Docker container, everything that the application needs is put onto one Docker image. You will have the host OS with the Docker or container application running on top of that, and then any shared libraries that they need and the application themselves will be on the Docker image. We can really take advantage of this in the DevSecOps process to help make our security testing a lot quicker and a lot easier. We can use it to organize all of our security tests and put them into one container that we can easily hand to an application development team. By using this method, we can really ramp up security from one application to hundreds of applications by being able to just take a container and hand it all to the different development teams that we want to do testing. We can create different containers for similar applications. You can have one container for Java applications, you can have one container for .NET application, and so on and so forth. So you don't have to have one container for all your different type of applications, and these containers will put all the different tools that we identified in earlier slides in this video. And once we have our containers built, we can integrate it with the automation server that the development teams manage. If they are using Jenkins, they can take our containers and they can integrate them with their Jenkins environment, so that every time they run a build or every time they perform some automation, they can run our container as well that contain all of our security tests. One advantage of using a container is being able to use an artifactory. An artifactory is a central repository for our containers that allows us to keep our containers up to date. So one of the principles that we talk about in DevSecOps is to not be afraid to change. So if one tool doesn't work, swap it with another tool. If one process doesn't work, swap it out for another process. But by using Artifactory, we can help keep our security image up to date. When we make changes to the tools that we use or the processes that we use, we can update the Artifactory with our latest Docker image. And the next time that a development team goes to run our tools, it will update it with the latest set of tools. We have talked a lot about leveraging our own processes and using what we already have in the past. So let's talk a little bit more about that topic and also try and answer the question, where do I start? The best answer that I have is start easy. Don't try and start with the most complicated application. When I first started rolling out DevSecOps to different teams, we didn't do a great job of choosing the right applications. We choose teams that maybe didn't have strong CI/CD processes in place, or maybe use the most leading edge technology. And those aren't really a great place to start. So the best answer is start easy, and also find a team that's passionate. There's always that team that really wants to do the right thing and work with you from a security perspective. Find that team and work with them so that they can help you iron out any of the problems you find in the process. And start with a standard language toolset. Start with something that's a little bit easier, like Jobber or .NET. Maybe not some of the newer technologies that don't have great security testing tool out there yet. And remember, the tool set doesn't have to be right the first time. You can try and adapt and see what works. When we first started rolling out DevSecOps, we tried to try 2 or 3 different tools before we found the one that actually worked and that we settled on. It's a matter of funding what's right for your team from a balance of technology, false positive rate, and what you are really looking to test. So don't be afraid to fail and try again with a different tool. One of the things to keep in mind when rolling out DevSecOps is get out of the way. Make sure that you provide the team everything that they need to succeed, but don't be the one holding them for completing their sprint or completely their testing or the point to production. So where do we come in? We turn ourselves into advisors and coaches, and that DevSecOps world, we aren't the ones actually doing the work anymore, but we are the ones helping the teams and coaching them and showing them what they need to do. At any of the security checks that we may have done in the past, like authentication checks or password complexity checks, we need to be turning those into code and working with the development team to make sure that those are automated and put into their process. And I know I have said it once, but I'll say it again. No PDFs, no hard documents. Those are not helpful in a DevSecOps world. We really want to get the information to the development teams in a way that they can consume it. This is an example of a process that many CI/CD teams might use. They may store their code in Bitbucket, use Jira for task tracking, use Jenkins for automation, use Ansible for configuration management, and so on and so forth. So when you engage with your team, make sure that you understand what is in place. And once you understand what's in place, take your security process and work that into DevSecOps process. You want to make sure that our process works with theirs, and that we don't force them into what we want them to do. And the tools in the process that the security team uses should work with different processes. Not all DevSecOps teams will use the same tools, so we need to make sure that we are flexible enough to be able to adapt to them. So maybe one team uses Jira and the other team uses Quality Center, but process build your process so that it's flexible enough to adapt. Before we engage with the DevSecOps team, there are a few different things that they should have in place to really make sure that DevSecOps is successful. The first is automated builds. We need to make sure that the automation is in place so that they can automatically build and push their code to the next environment. They need to have some sort of an automation tool like Jenkins NS place to we can integrate our DevSecOps process with their automated tool. Task tracking system is something that's important to have in place. Once we get done running our test, we have to have something to do with the results. Like I have started we don't want to give them a PDF, so we need to have some place for the results to live. So they should have a Jira quality center, something along those lines, so we can take our results and push them to the development teams for them to be able to work. And finally, we need a reliable unit test. It's really important that the development teams do the testing on their own. And as we start to look at some of the newer technologies like interactive application security testing, they really rely on good unit tests to be able to run their suite of security tests. There are some security processes that we should have in place when we engage with the DevSecOps team as well. Firstly, we should have some sort of security testing in place, whether it's static, dynamic, or interactive. Something should already be in place that we can integrate. Another thing to keep in mind is that if you are doing mobile application development, we should have some sort of mobile application testing already in place. We should have vulnerability scanning in place like Qualys or Nexus, something along those lines. I like to talk about AST a lot because I think that it works really well in DevSecOps world. You can see that you have an application in the top and AST will have a hook into application using instrumentation. What that means is that whenever the application is used, the ES security tool will be able to see the code and the data going back and forth between the web server and the application server. This is why I mentioned it is so important for dev teams to have good unit tests in place. While the unit tests are running, the EST application on the background will be doing the testing and automatically pushing any defects or vulnerabilities found to the task tracking tool or the chat ops tools that the development teams has in place. And always remember, it's okay to have different processes for different applications. Applications can be handled differently, right? Job applications can have one suite of test, .NET application can have another suite of test, and kind of show some example of different processes for different apps. You can see here that maybe with some application the development team would use Maven and Jenkins, and you will have the contrast or some other ES tool and Zap to go with it for dynamic style. Another team may use TFS and Bamboo, and so may decide that SonarQube and Burp and Nexus would go best with that process. You can be flexible with your process, and you can have multiple applications that you use depending on the type of application that you are testing. Let's talk about the ops side of DevOps and how DevSecOps fits in. It's easy to focus on application security because like traditional development teams, network security and application security were handled separately. With DevOps, we have to consider security across the whole platform. Remember, cloud is built for automation. Good DevOps team should include infrastructure solutions as a part of their development process. Things like server creation and network configuration should all be automated as part of their build. Security teams should take advantage of that and use ops checks in their DevSecOps toolset. There are a lot of ops automation that can be done, but here are a few examples. The most common is vulnerability scanning. Those like Nexus and Qualys can look for things like outdated operating systems and missing patches on servers. Another thing that can be automated is the network security group review. You can use automation to check and make sure that your networks are not overly permissible in the cloud, and that you have them locked down appropriately by application group. Another thing that you can do is look for patching compliance. You can look and make sure that all the systems are patched, and when you find non-compliance, automatically notify the development teams. The last thing you can look for is encryption at rest. In the cloud, everything should be encrypted. You can use DevSecOps automation to look through all the data on the cloud and ensure compliance to this requirement. Development and operations tools should be part of a single tool set. They shouldn't be broken out into separate buckets. Although they are part of the DevSecOps toolkit, uh, they do have different focuses. The development tools focus on detecting problems before they make it to production. The operations tool focus on detecting, protecting, and blocking applications that are already in production. As we stated before, DevOps, cloud, and automation are all partners. The key is integrate security into each of these areas to make sure DevSecOps rolls out is successful. There are a lot of free tools that we can use and add to our desk side ops toolkit. One of the most common tool that I use is find sec bugs or find security bugs. It's strictly a Java static tool that we use to scan the source code of Java applications, but it's pretty robust. It can integrate into your Jenkins environment. It has really good OS top 10 coverage and CWE coverage, so that you can actually map any of the defects that it finds back to known vulnerabilities. And best of all, it can actually integrate with the IDE, so you have the flexibility of giving the developer this tool and having them run it when they develop their code. Or you can actually include it in your automation in your toolkit and run it automatically, or maybe both. There's no harm to making it run twice and making sure that the tool has actually been run. Another tool that I use a lot is the OWASP Z attack proxy, or we can call it ZAP. It is an open source dynamic scanner, so it's going to try to hack your website. It is going to spider your site, and it's going to look for any places where you can input data and try and manipulate that and hack its way into the application. It's been around a long time, and so it's very mature and well maintained, and it actually works very well for automation, better than some of the commercial tools that I have used. It even comes with a Jenkins plugin, so that you can implement it at the Jenkins level, or in your Docker container that you have for your toolkit. A third tool is SQL Map. I use this one a lot when people want proof that their application is susceptible to SQL injection. Nothing makes them believe you better than when you hand them a copy of their own database. This tool can be run manually, or it can be included in your toolkit and run in an automated fashion. Switching over to the operations side, OpenVAS is a vulnerability scanner. It's free, and it's an alternative to some of the commercial tools like Qualys and Nexus. It maybe isn't quite as robust. It does a very good job, and I use it quite often to run routine scans on external networks. Recon NG is not actually a security tool that you use to try and find bugs, but it's more of a recon framework, meaning it's going to go out there and do Google search and do GitHub searches and look for things that you don't know are exposed. This application I use quite a bit to run or on our known IP ranges and look for applications that maybe I don't know exist. And once I find them, I do a little more recon and find it into some of my other tools looking for SQL injection. You can also use recon ng to look for source code code that is on GitHub. That maybe developers accidentally checked into a public repository. And finally, this is the one of my favorite tools, and it's called Glue. And I use this to tie everything together in our toolkit. Glue is a Docker container that you can use to put all of your tools into. Out of the box, it supports a lot of tools like find stack bugs, contrast, fortify, and it takes all the results from these tools and it allows you to export them in a format that makes sense to you. You can export them in a JSON format that you can use to plug into a web service for a tool. You can export them directly to Jira as well. This goes back to the container concept that we talked about in our desk side ops pipeline. And this is one of the key tools that I used to manage that container concept. A little bit later, we are going to take a demo of this Glue project and show how this actually works and how we can use it. Now that we know of a few of my favorite tools to include in the pipeline, let's talk a little bit about more about some books and some handbooks that we can use to help us with our process. These are three of my favorite resources that I go to often and just refresh my memory on what they say. I think each one offers a little bit of a different perspective on DevSecOps and can help in different ways. The first one is DevSecOps Playbook, written by Dave Shackelford for Sense. If you don't know Sense, Sense is a great resource for security training and awareness. In this playbook, he divides it into three parts. The first part, he spends a lot of time talking about DevOps, what it is and what its goals are, and then he shifts into looking at your current controls and how they fit into a DevOps control cloud model. And at very end, he talks about how to fit security into dev and ops. The continuous application security playbook is written by a vendor, but the author Jeff Williams does a great job of talking about how to integrate security into the DevOps process from beginning to end. The main point that Jeff drives home is that security should be everywhere and it should be continuous threat intel, continuous security integration, and continuous attack protection. The final source I have is Awesome DevSecOps. Kind of like the name says, it's an awesome list of DevSecOps information. It includes everything from trainings, presentations, tools, dashboards, and so on. It's a great list, and in the spirit of DevOps, it changes as the community finds things work and things don't work. Thank you, everyone. If you have got any query or concern, then always remember the fastest way to reach out is the comment box. Pick up your keyboard and start typing in the comment box. I will get back to you at my earliest. Alternatively, you can drop me an email at cybitcyber@gmail.com. Also, do not miss to subscribe to my channel and press the notification bell icon to be aware of any new courses that I will publish. You can connect with us at LinkedIn, Facebook, Twitter, and Instagram to get yourself updated with latest cybersecurity industry trends, documents, and various articles. You should use our unique ID Cybit Cyber to find. Please subscribe to my channel Cybit Cybersecurity. Press the